Alright, so finally we have the unknown elements. So you'll notice that they have those really weird names that even I don't want to try to pronounce. But basically, if, like I said earlier, if you speak Latin or know Latin, these just translate to the number. Okay. Now, like I said earlier, again, all of these have been named. But if you see in the future anything like this, it just means that they've recently been discovered or synthesized, or every once in a while they are currently theoretical, which means that they haven't actually created them yet. Okay, we've got some more videos that deal with this. So they are created using a particle accelerator such as the Large Hadron Collider, or the LHC, which is in Europe. It's 20-something miles in circumference, I think. I'm not entirely sure, but it goes over, like, it's actually underground, and it goes across several different countries, and it's kind of a collaboration between all of them, but and other various countries. But basically, particle accelerator is used to you put these elements, or the atoms, into the particle accelerator, and then the particle accelerator really just spins those elements around and around in a giant circle until they reach a certain speed, and then the Large Hadron Collider will actually smash them together. And then it's all set up so that there are readings that can be taken at like the point where they're smashed together to try to create new elements. So, and other different discoveries and things like that. But if you've seen, I think it was Iron Man 2, when Tony Stark starts building that thing with the coils in his basement, and he starts like tearing up part of his workshop or whatever in order to create that new element to fix his little mini arc reactor that he has. That's what he's doing. He's actually creating a hadron or collider. It's really small one, really small one, but for the most part, that scene kind of sort of gets the principles right. It's just way too small, and it would also be relatively difficult to just, build it in your basement. Even Tony Stark's basement. But, yeah. Okay, so again, looking at periodic table, this one emphasizes even more different kind of information. So you'll notice that like hydrogen, neon over here, all of these are written in blue, and then you've got mercury and bromine that are written in red, and then you've got several that are basically just outlines, and then just the regular filled in ones. So this here is showing you that key. So basically the ones written in black are solids at room temperature. The ones that are just the outline are synthetic, so they were created in a lab. And then you've got the two red ones, mercury and bromine, are the only two liquids, and then the blue ones are the gases. Okay. And you can see that this was in 2013, so they had actually named two of these elements here, flerovium and livermorium. And then another thing to point out with this is actually something I added, but I added in the ion charges for each group, the most common ion charges for each group. So you've got your first group here that likes to form +1 charges. Second group likes to form +2. Then you skip the transition elements, the transition metals, because they're so weird, and you go over to what is actually group 13, has the +3 charge, and then you go carbon's group is ±4, nitrogen is the -3, oxygen is the -2, and fluorine is the -1. Okay? And then also what I was talking about earlier with the lanthanides and the actinides, You can see here they go directly from 56 and then skip over 57 to 71 and then just go to 72. Okay, so this is what I was talking about with that. Okay. And then sometimes you might look at some of these elements and wonder where in the world their atomic symbols came from. So this is kind of to explain some of that. A lot of that comes from Latin. No surprise, surprise. Chemistry, science, and Latin. But I thought this was kind of an interesting thing to look at. So like copper is Cu. It's actually from cuprum. Okay, that's what it was originally called. Gold was aurum. So Au. Iron was ferrum. And a lot of times we'll also talk about things that are ferrous, things like that. Ferric, that's still referring to iron. I like lead. It's Pb, but it's plumbum. It's always fun to say. And then when you get down to silver, you've got argentum, and then wolfram is another one of my favorites for tungsten. Okay, so that's where some of those weird symbols come from. It's not just that they were like, oh, well, we already have a T or a TN or whatever, so let's just make it an SN. Or mercury, you know, doesn't have an H or a G in it, so why don't we make it Hg? Makes a lot of sense. But it's actually from, you know, Latin, because it's low Latin. But that is it for this section, so we'll continue talking about matter and general properties in the next couple sections. But